All right, so we're going to go ahead and jump into Andrew Hall. Ionic winds shape the Earth. Let's do it.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In the first three parts of this presentation, Thunderbolts contributor Andrew Hall has explored the electrical nature of wind and powerful storms on planets throughout the solar system, including Earth. Of course, mainstream geology tells us that wind plays a significant role in shaping the landscape of our planet, supposedly incrementally over countless eons of time. But as Andrew has proposed in numerous
This is some cool stuff. You probably haven't watched any of it yet. Uh, but like this is the actual formation of the planet. Like this explains what science has been trying to explain in the simplest terms possible. What actually happens when the planets form and how mountains are shaped and canyons are shaped. It all ties into the end times. Like this, how I got into this topic was because I think we're in the end times. And so, what's about to happen and what I believe is described in the Bible is about to happen ties into what they discuss here. And the forces involved is going to come to play again. Uh, and they go into better scientific detail with how it happens than I can. So I just do it like a reaction video. Uh, because it's information that needs to be out there, and so I'm just letting it go.
past videos, the Earth's wind-sheared landscape reveals unique patterns which may have been produced by ionized shock waves in primordial electric storms. In part 4 of this 10-part series, Andrew argues for a new perspective on wind in Earth geology, not as a slow erosional force, but a short-lived and violent one.
If you study Earth's surface and look at details in its form, there are obvious patterns. Arcing patterns of mountain ranges and island chains, strange swirls and looping cracks on the ocean floor, and on close inspection there's harmony in the shape of mountains and other terrain. Sometimes it's geometric with triangles, arcs, and stars.
Like we just did the video yesterday talking about the electric eye, and you can see this right here is the same pattern as lightning. It's the same way that the plasma discharge happens when you have lightning. And they're going to get into that a little bit more, but I've got to stop it for copyright reasons. So I might as well explain a little bit of what I see when I do that.
Star patterns, but usually it's more fluid, like a crazy paisley.
Like that looks like a weld if you look at it.
Consensus thought is this is a result of a series of unrelated events that occurred over billions of years, driven by the slow churn of Earth's crust subducting the continental plates and the constant wear of erosion. EU thinks it didn't happen that way. We think it was caused by electricity, and the patterns we see make more sense if viewed in the context of our theory. The face of the Earth was shaped by three primary means.
And that's got a lot to do with why we're covering this, is because there is a plasma event about to happen. And like that's what the Bible describes to us is the plasma event. And this shows it. There's this other guy, Gil Broussard, that shows the tracking of this planet that I think is going to cause this. And I tie all that together in the series.
Volcanic eruption, lightning, and wind.
Isn't that an amazing picture? Like, I love the pictures of the lightning. Like, I always have loved lightning.
It occurred in primordial storms, which ionized the atmosphere, charged the ground like a battery, and discharged energy the same way we see today: earthquakes, volcanoes, and storms. Only these storms were beyond biblical. They occurred before man arrived. What we are talking about today are the storms of creation, which shaped the face of the planet. Because wind played the biggest role in laying and piling the
WMO. I don't know.
sediments we live on, its effects are most visible. The evidence is in supersonic shock waves imprinted on the land. Once you start recognizing the characteristics of wind-formed topography, it becomes almost impossible to ignore. To identify wind direction, look at
Oh.
mountains. Mountains, not volcanoes,
Huh.
are all essentially wind-blown
That's interesting.
regions, with exceptions for shifting wind conditions.
Like I'm looking for some gigantic plasma discharges, like the size of this mountain, type lightning flashes. That's what formed the the mountain chains and the valleys and the canyons and stuff is a plasma discharge, a lightning bolt about the size of this mountain that stayed there for a couple of minutes, like dragging. And they show how that works. It's crazy. Okay. Researchers for satellite images.
Conditions, a mountain's shape will show a
I'm going to look that up.
windward and
We're going to get that knowledge out there.
leeward side like a dune. The leeward side is generally steep and slab-sided, and the windward side dips at a shallower slope. The windward side actually portrays the shape of the wind itself as pressure waves undulate across movable sands and mold them. If the wind reaches Mach speeds,
that's big.
Standing shock waves reflect
Like that's a couple states
from any protrusion in the wind's path, causing a sharp change in wind direction. Distinct patterns form at this crease, called shock diamonds, where the wind direction changes abruptly. The reflected standing shock wave forms a fan-shaped interference pattern of compression and rarefaction. This pattern can be found on most mountain forms, including Cordillera Mountain arcs, continental divides, lone Inselbergs, and basin and range. Dust-laden supersonic winds deposit the heavy cargo where the crease in the wind forms. A tetrahedron-shaped zone of rarefaction, or low pressure, develops at the root of the standing wave. It's called a separation bubble. Windborne dust collects in this bubble as the wind deflects upward with the shock wave. As material deposits in the separation bubble, it forms a new barrier to deflect the wind, which moves the standing shock reflection backwards into the wind. The separation bubble migrates into the wind with the shock wave, causing new dust to overlay the old in layers that stack into the direction of the wind. The shock wave is a discontinuity in density, temperature, and ionization. Remember, we're talking about a primordial storm where much of the atmosphere ionized. So standing shock waves reflected from the ground back into the clouds, providing a path for discharge. The separation bubble is not only a
I really like having names to look at. I do. That helps a lot.
Pressure sink, which collects heavy matter. It is also
Capital
a current
weather,
sink, being the lowest potential region connected to the high potential current in the reflected shock wave. It therefore draws current to bake, compress, and fuse the deposited dust. It creates a distinct pattern on the windward side, dragon's teeth, triangular buttresses, or sometimes called flat irons, formed by the sonic ionized shock waves of supersonic winds. They rise and fall in amplitude and wavelength and display harmonic frequency shifts, as well as many other features which can only be produced by the sonic effects of supersonic winds. Please see the arc blast and monocline articles previously published for more details. Understanding how winds form these shock patterns and examining the result on the landscape reveals a wealth of information. Let's consider this very simple dune called El Guaje in the Sierra Oriental Mountains of central Mexico. The shock patterns of triangles is very apparent on its windward side. This next image is annotated to show El Guaje highlighting the 4 consecutively formed pressure ridges that are visible. The first is highlighted in green, and it's almost buried by later deposition, so only the tops of its buttresses are exposed. The second is marked in yellow, and is another small ridge caused by a period of weaker winds. It's also partially buried by the third and the largest ridge, which obviously deposited much more material. Large triangular buttresses at one end of the large ridge shrink in amplitude with geometric progression until they almost vanish. This indicates the jet stream velocity transitioned from supersonic to near subsonic velocity along the wind front of this dune. The faster
Supersonic winds, like the concept of that is pretty amazing if you think about it. Like winds moving faster than the speed of sound. Like that's what he's talking about. So that is obviously from an outside catalyst. Like that doesn't just occur naturally. You don't have a hurricane. Like our greatest hurricane, we just had the most powerful winds ever recorded, sustained winds recorded, right? In this last hurricane that just came through. And it was like 120 miles an hour. Like that's nowhere near breaking the sound barrier. So the wind to be moving faster than the speed of sound is just a little bit mind blowing. Like that's pretty crazy.
jet stream region advanced the growth of the dune, depositing material faster and pushing the shock wave.
And like what he's talking about is you got a really hard wave of wind, and then it drops down below the speed of sound, and that causes this little lump right here, and then another hard wave past the speed of sound, and then drops down, and repeat all the way up. That's what he's talking about. It's like a reverberation of the winds. It's going faster than the speed of sound and then slower, faster and then slower. Like that doesn't occur just on a normal basis.
Wave into the wind. It advanced the ridge line at the top of the page into the wind, shown by the violet arc, and built this portion of the mountain thicker, taller, and with larger amplitude reflected shocks, forming bigger triangular buttresses. Each layer of the buttresses is formed by a new shock front from winds impinging on the last layer. New shock fronts formed as the wind gusted, piling new layers on the old.
That's crazy.
A final diminishing
1,000 miles an hour. That's crazy.
wind created a final fourth shock front, which has deposited a small pressure ridge, shown in purple along the foot of the mountain. The highlights obscure natural features. So please contrast the Ionic.
I didn't realize it got that high. There's a lot of things that when I watch these things, like this is like my second or third time watching through these, and like I still pick up like processes and things that I didn't before. I did not know that it like I was trying to remember what the speed of sound is, and I'm like I might have to look it up because I don't remember what Mach 1 is. But like 1,000 miles an hour is like insane. Like I can't conceptualize moving that fast. Like I don't know. Like that's scooting. You know, like I drive 120 in a car is my top. Like the top I've ever done was 120, and like that was some scary shit. Like I did 100 on a motorcycle, and that was some scary shit. I could not imagine going 10 times that fast. Like, that would be some scary shit. You know? Like, but yeah, that's cool though. Like, 1,000 miles an hour winds, like, that's booking. That explains why there ain't shit on top of mountains.
Annotated image with the first naked image to see the buttresses better. The winds that created these ridges were like any storm, just quite a bit more violent. They stiffened as the storm grew, reached a crescendo with electrically charged, gusting blasts at Mach speeds, and then ebbed away. Their formation precludes any notion that the winds that created them were caused by a meteor or comet. A large impact might produce supersonic dust-laden winds, but they wouldn't crest with the first shock wave and then dissipate, not slowly build to a crescendo as these mountain ridges do. Take a look at the surroundings of El Guaje Ridge, and it becomes even more apparent how it was made.
I love all things knowledge. Like, I'm trying to expand a little bit of knowledge with these clips. Like, I do the music because people watch the music, and I do a little science. I'm going to try and get some MBTI in, and then, but I don't know if I'm going to get there before the second half of the show. The second half of the show is all the controversial stuff. So I'm trying to get at least a little bit of knowledge out on YouTube, you know?
It's part of a
I
larger
love this
structure,
stuff. I love it.
an oblong
No, and I absolutely do not think the Earth is flat. I personally have seen the curvature of the Earth. So nobody will ever convince me otherwise. I know what I know. So
crater that's 200 feet deeper in the center than outside the rim.
it is awesome. Like I that's one of the great things about being in the Navy. Like they can say what they want. I have a gift, right? I can see level. It's kind of crazy, but like within an eighth of an inch from 5 feet away, I can tell you if anything is on bubble level. And so, when I was out to sea, we're out in the middle of the Atlantic Ocean. There is nothing to see but water, and it was a clear day, so like the water is like flat, and so you can actually see the fall off of the Earth, and so nobody will ever be able to convince me that the Earth is flat, ever. I don't care. Like they misinterpret the Bible on such a grand scale anyway that them quoting Bible verses at me for it doesn't affect me because I know better. Yeah, yeah. The good old chair force. I've got two cousins in the chair force. I give them hell all the time. Like we give everybody hell. That's kind of what we do.
The pressure ridges, including El Guaje,
Right.
form the rim of the crater.
Like it's so simple to prove. Like the way that shadows fall in your own yard can prove to you the curvature of the Earth. Nice. Thanks, Jen. You just helped me get an award on Restream.
Crater. It wasn't made by an oblong meteor. This is the result of a downburst wind. The pressure ridges are the rims of the crater with triangular buttresses showing the wind direction as it blasted the Earth like a blowtorch and blew out radially, depositing dust along the standing shock waves it created. The outward blast is interfered at the top end by two ground mountains formed by lightning discharge, which altered the wind flow around.
It's good to have somebody that you can trust about those situations. Like, 'cause there's a lot of craziness out there. There is. It's kind of why I do what I do. Like, there's a lot of craziness.
And disrupted the symmetry of the crater. Taking another step back in altitude reveals this entire mountain region in Mexico is shaped by a turbulent shear zone in the wind. These mountains were formed by unipolar electric winds screaming from the south and mixing into plasma storms along the shear zone with an opposite polarity wind screaming from the other direction. It's eerily similar to the turbulent shear zones adjacent to the Great Red Spot on Jupiter, creating kinked circulations that have a crab claw shape. I call this mountain.
It does. Like, it's crazy how much nature mimics itself. Like, there's a mathematical pattern that's laid out in the Fibonacci sequence. I'm sure you've heard of it. And, like, all of this could be laid at the Fibonacci sequence as at its feet, right? And so you see things in the greater scale and you see them in the smaller scale. And, like, looking like the bones of a fish, it kind of look like a butthole, too, if I'm being honest.
Formation in Mexico, the Mexican kink. Turbulent winds fold
Right.
back and forth to make these kinks.
I'm sorry
They
for your loss.
also fold up and down and twist into tornadoes, blowing and sucking at the land. In turbulent zones, the downdrafts form cyclones that are often stretched out of round into oval, polygonal, and U-shaped structures. The winds are electric current, so these turbulent kinks are semi-steady state.
And like I just picked up on that whole the winds are electrical current thing, watching the thing yesterday. Right. And the way that the ionization works, it really just clicked for me yesterday. I've watched this I don't know how many times. They've talked about it I don't know how many times. And then it just like it clicked for me. Like, holy crap. I could see the magnetics involved in the way the winds blow. And that was some cool stuff. Like, even in trying to get science out for other people, I'm learning things. So I'm not sure if he does that just to fuck with people though. Like, I, I'm not sure. Like, cause sometimes, he be trolling. So, uh, I don't know if he says that or not, just to mess with people.
Keep their form for a long time molding the land.
And like, I let people have their beliefs. Like, I am not here to get rid of anybody's belief in anything. Uh, so if he thinks that the world's flat, like, blessed be, do your thing. Like, it doesn't matter in the grand scheme of things whether somebody believes the earth is flat or if somebody doesn't. Like, I know for me that it's not. But like, you're welcome to your beliefs, whatever they may be. Like,
Downdraft turbulence also means there's updraft turbulence. So next to downdraft craters in Mexico are mountains formed by updrafts.
I love his energy. Like, yeah, I do. Like, he's just like a bundle of turbulence.
An updraft wind will create a dome or ridge of layered deposit with the rim around it also. But the inflow to the updraft leaves the triangular buttresses from shockwaves on the outside of the mountain pointing inward. The updrafts deposit linear and lobe-shaped mountains around and between the downdraft craters. The turbulence is in a shear zone, so deposits occur in narrow lanes between conflicting winds. Updraft deposits are composed of more material than craters and have the triangular patterns of shockwave reflection on their flanks. As it relates to clouds on Jupiter, a long rising column like the one highlighted here would create such linear mountains. One can see the dark depths of the hole in the clouds from which the updraft column rises. The winds roll upward from the ground and curl over, leaving a broom-swept linear ridge on the land below. The turbulent kinks are fractal forms, so taking another step back in altitude reveals the fractal crab claw shape emerging at a larger scale. The smaller feature with the crater shown above is nested with...
I thought that this was a more active video. Like, I thought this was the one where they showed the actual formations. And so, like, I know that this is kind of dry watching. I appreciate you hanging out. But there is good science in this. Like, there really is. Like, the way that they're showing, like, they lay a lot of groundwork in their videos. And I was trying to show the necessary parts without showing all of the groundwork. And I think I just got into a groundwork one instead of one of the active ones.
Within this larger repetition of the wind pattern shown aligned along the same axis.
Bullhead bundle of
Nested
joy.
fractals are very evident in Jupiter's clouds
I love his shorts. Like, I do. They're great.
as well.
I like the music too, though. So,
The similarity between Mexico's mountains and Jupiter's clouds
like, he's real in your face with it, and he does it in a way that's not aggressively in your face, but is like just trolling in your face the whole time. And I love that. Like, that's a way to do
is
it.
due to capacitance in the planetary circuits. The strongest winds are vertical winds driven by the electric field. Following is a sample of images taken from the southern leg of storm centers that molded South America, Australia, Africa, and Eurasia. The winds pushed and pulled on the land with electric force, literally molding it from wind action above and volcanic action below. The fluid shapes are a dead giveaway for magnetohydrodynamic forces, but deeper levels of
Magnetohydrodynamic forces. That is the magnetic influence over water as it rises and falls.
evidence are there in Mach speed sonic shock effects, arcing effects, and sputtering effects that provide a holistic electric picture of everything that was happening. Look close at the following images and note patterns of stratification and liquid deformation evident from waves of heat and pressure. Turbulent winds lifting off the land, arcing across the sky, and returning in downdrafts were filaments of plasma that varied in charge density and cross-section too. Take note how a tornado is a coaxial circuit, with the outer wall of the tube being the fastest, most dusty region, and the inner core often a clear draft.
See, before I started doing reaction videos, like I got pretty heavily black pilled, and then I started watching the reaction videos. But before I did that for like 3 years, this is all I did. Like all day long, every day. Like I'm disabled, so I don't get to work. I do my house stuff. Like I clean house and I cook and do all that stuff. But like I don't get to go to work. And so I would just sit around watching science shit all day long. That's what really woke me up was watching these alternative scientists show, like, without a doubt, that, okay, this is what happened. And then see mainstream science be like, just shut up, bitches. We don't want to hear from you. And these guys are just like hammering away at it. And so that's what really inspired me to make sure that I work this into the show, is because most people don't watch science at all. And if I can break down and make it a little bit entertaining at least, then maybe some more people will pick up on it and it will become mainstream science. That's what I want. The cornfield art, the mazes or the alien visitations.
The plasma
I'm interested.
filaments of primordial storms varied in dust content, charge density, and velocity in cross-section as well. The result is stratification of mineral deposits vertically, where the rock morphology and mineral composition discretely change from the core of the feature to the walls of the feature and then to the outer surroundings. It's a coaxial arrangement. The following images show where the storm pulsed and ebbed with current, stratifying these layers of dust with different composition from the inside out, where the coaxial up and down draft.
That is an amazing picture. Like I get it. They're talking about the forces that created it, right? But like, look at that. Like that is just. I wish I could get that off of there while it was paused, but that's like an eye. Like that's looking at you. That's just great. I love it. I love it.
Draft winds created domes
I love the earth.
and craters. Layering of varying mineral composition are particularly evident where winds abruptly change direction from horizontal to vertical at the rim of craters and the buttress flanks of mountains. There, charge densities in the shock waves and the effects of magnetic pinch were the greatest. The stratification of species within the electric winds of Jupiter matches the pattern of stratification in landforms here on Earth. They are coherently layered from the inside out of each turbulent kink or vortex.
Well, that's funny. My people are from Tennessee. Like they're McNairy County, Tennessee is where my dad's family came from. So well, I've been up there a lot. It does look a little bit like that. Like the break offs and yeah.
Unmixed
And like that's right where Mississippi, Alabama, and Tennessee meet is where McNairy County is. By Pickwick Dam.
by the turbulence in accordance with charge densities and currents that are primarily
Like my grandparents came here in part because the TVA took over part of the property when they were making the dam.
moving up and down.
They do. They do.
That
seem
electromagnetic fields sort species and recombine them as predicted behavior in plasma. We use a multitude of techniques in manufacturing based on this fact. Different materials respond to magnetic fields differently. The electric field responds to charge density, so shapes itself around conductive flows of material and vice versa. The result is stratification, and it's apparent the stratification in Earth's landscapes matches the stratification in Jupiter's winds. Some mountains do not conform to the wind-blown dune shape, exhibiting triangular buttresses on both flanks of the mountain, or not conforming to the windward-leeward angle of slope. This doesn't mean they're not dunes, but indicates they were formed subject to shifting or competing winds. In some cases, mountains formed as sastrugi, or linear deposits parallel to the wind in the shear zone between channels of wind of different velocity. So it's possible, by looking at the land, to deduce wind patterns. Following this method of identifying wind direction from triangular buttresses in the mountain ranges and craters that are formed, the next image shows the Colorado Plateau with wind-formed pressure ridges annotated by blue lines. These are pressure ridges formed perpendicular to the wind. Each line is drawn parallel to a pressure ridge, and perpendicular hash marks indicate the wind direction. The red lines on the map indicate pressure ridges formed parallel to the wind at shear zones between the conflicting winds. This map provides one layer of dimension to the storm, the dimension of ground level winds. But to add another layer, we can look at the domes and craters that formed by updraft and downdraft winds. The red areas on this map are updrafts, the yellow are downdrafts, and blue are precipitation footprints. Adding this layer of information to the map of pressure ridges,
Doesn't that look like the Nazca lines? Like it could be outlining out in the Nazca lines. Like this could be a dragon and like
produces a wind map of the Colorado Plateau and the Rocky Mountains that looks like this.
I'm so glad I don't live where we get snow regularly. Like, we had that winter storm last year, and that almost killed me. Like I don't do well in the cold. Like my body doesn't react well, and so I'm so thankful that I don't live where there is regular snowfall.
Now, to describe
It's beautiful. I just can't do it.
this storm, there are two jet streams coming to the Colorado Plateau from the north. One poured through the Snake River Valley, arcing east towards Yellowstone. The other jet stream swept into the Great Basin, rippling Nevada with rows of wind-blown mountains. There's an S-shaped range in central Nevada that defines a center of rotation, as this mesocyclone scraped the ground like one incredible tornado. It downdrafted into two streams, one pressing down on the Uinta Valley in Utah, and the other sweeping northern Arizona, forming much of the Mogollon Rim. The Great Basin storm also spun air south.
Yeah, in Illinois was a terrible experience for me. Like I was in I was in Great Lakes, like just outside of Chicago and Gurney Mills area, and like it was a terrible experience. Like I'm sorry, I don't know where you live, but like I hated Chicago. Like I hated it altogether. But I didn't like New York either. So
South, bypassing the rotation to help define the Sierra Mountain Arc and scour the Owens, Amargosa, and Death Valleys. The Sierras were formed by winds from the west, not shown here on the map, which pressed against the Great Basin rotation as the winds bypassed south. From the south, winds collected and then split, forming the Mexican Kink and the El Guaje Mountain.
the Mexican kink.
They reformed in a ground-hugging laminar flow near Four Corners, sweeping across Colorado, Utah, and northern Arizona, laying the foundations of the Colorado Plateau. The southern wind fed a multi-vortex cyclone over the plateau, where it divided its path to feed thunderstorm updrafts. These winds threaded up and back down through mesocyclone-cyclone pairs in looping currents, like lacing a shoe. The updrafts are defined by San Rafael Swell in Utah and Monument Valley and Black Mesa in Arizona. Winds from the south also circulated to the east over the Great Plains to be sucked into the cyclone through thunderstorms that built the eastern face of the Rockies.
That's funny. I think right here is Hopi land, right? Where the Hopi homeland is. I'm pretty sure it's right in this area here. And like that is just outside. They have the Blue Star Kachina. I've done a video on that. And like, that's within sight of all of this activity. Like the plasma activity, the wind activity, the formation activity, but in a safety zone. And they're told to stay there as part of their mythology. And that's interesting that like looking at it here, when it illustrated where the actual activity is taking place and the actual formation of the mountain range that they don't hold it sacred. They don't hold things like that sacred, but it's like a sacred thing that this mountain in the view is part of their homeland. And that's just, it's an interesting interplay to me.
These downdrafted, forming huge craters in the mountains like San Luis Valley in Colorado. Each of these features, the Great Basin mesocyclone, the multi-vortex cyclone over the Colorado Plateau, with arching colonnades of mesocyclone-cyclone pairs, can be identified in the Great Red Spot on Jupiter. It's because the shapes and actions of the wind are driven by the fractal process of charge diffusion in the planetary circuit. The difference in chemistry and
Yeah, like it's literally part of their mythology to keep that in view, but not to go to it. And like, I did a whole, like, it was an hour long, or almost an hour long thing on the Hopi prophecy and how it ties into what we were looking for and the electric universe. That was my first suspicious observers video. And we were talking about the Hopi and suspicious observers and how it plays together. And it's funny that I could see that here. Like that's the area they're talking about. Is specifically the area that I was talking about. That's pretty cool.
thermodynamics of Jupiter's atmosphere compared to Earth's doesn't make much difference because circuits are the forcing mechanism of nature. So this completes the view of winds at the very eye of the storm. The Colorado Plateau received the hottest plasma torching in North America. Surrounding areas were also ravaged by storm, but none so severely. In fact, the whole Earth was wrapped in storms. So we'll look closer at some of those regions, as well as more details on North America in the next installment. Thank you.
Yeah. All right. Y'all make sure you get back over to the Thunderbolts Project. Give them a like, give them a share, give them a sub. Throw them a comment down below and let them know you do appreciate what they are doing. It's a hard road for these independent scientists, and we need to give them all the support we can. This is going to wrap up the YouTube portion of this broadcast. I appreciate y'all hanging out with me, and I am praying for you every day. And I want y'all to know that, like, that is real. I do that. We're going to take a short 5-minute break. I will be coming back on the other side of it with the more controversial stuff, and it will be exclusively on D-Live. The replays will be available on Odyssey, BitChute, and Rumble. You won't get the clips until tomorrow, but the full show will be up today. And this is going to wrap it up, guys. So until tomorrow, this has been Pitt State for YouTube. We'll see you on D-Live.